On LR1-3, we are using inductive reasoning, deductive reasoning, and the segment addition postulate. So inductive reasoning is when we look at data and we recognize a pattern. So if I look at something like this and I say, okay, I'm going up 2, and then I'm going up 3, and then I'm going up 4, so my pattern tells me I'm probably going to go up 5 next time. Or if I look at this pattern and I say, okay, square, circle, square, circle, I'm probably going to have a square next. And when I look and I say, okay, that black space is rotating around my square, so it's going to be there. Now, some of you are sitting here and you're saying, no, Miss Cronin, it's going in a zigzag, so it's going to be down here. And still others of you are saying, no, Miss Cronin, it's just bouncing back and forth, so it's going to bounce back over here. And the truth is, we don't have enough of our pattern to tell which is which. So I would on a test or on a checkpoint take any of those, because there isn't enough to decide which one of the three. When I take those patterns and I make a generalization based on that inductive reasoning, that is called a conjecture. So if I put a rock in water and see that it sinks, and then I do it again, and then I do it again, and I say, aha, all rocks sink, that's my conjecture. My counterexample then is what is used to show that it is false. So if I find a piece of pumice and I put it in water and it floats, all of a sudden my conjecture of all rocks sink is false. It's not true, and I only needed one example of it not being true for the whole thing to fly out the window. Deductive reasoning then is when we start with one statement and a second statement and we use those to lead to the next. So if I say all MMW students are great and Susie Cream Cheese goes to MMW, then Susie Cream Cheese must be great. Okay? You're using things to logically lead to an endpoint. My segment addition postulate then is an example of that. And it says that if B is between A and C, then AB plus BC must equal the length of AC. And that makes sense, because looking at this length plus that length has to equal the whole length. So we're going to do some examples of this. On your checkpoint, you will need to draw out the picture and mark the little dots. But on your notes, I was nice and I gave them to you. So AB is 7 feet, so I'm going to fill in 7 there. The whole thing is 19. And I'm looking for BC. So just looking at this, I know 7 plus x must equal 19. So when I subtract 7, my length BC is 12 feet. We can also throw the alphabet into it. So I can get 6x minus 3, BC is 4x plus 5, and the entire thing is 32. I'll use some algebra now, so I get 6x minus 3 plus 4x plus 5 equals 32. Combine my like terms, and I get 10x plus 2 equals 32. So 10x equals 30, which means x must equal 3. To solve for AB, then I can go back and say, well, AB has to equal 6x minus 3. So I can say 6 times 3 minus 3 has to equal AB. So I get 18 minus 3 equals AB. So AB is 15 units. I can do the same thing with BC, or I can subtract. So I can say, well, I know the whole thing's 32. I've already used 15 units. So I've got 17 units left for BC. And some of you are looking at our picture and you're saying, this is way shorter than that. Like not just 2 units shorter, like a whole awful lot shorter. And you're right. But that is because this picture is not to scale. And if it bothers you, you can put a little NTS, not to scale, off in the corner. Okay, we drew this picture before we knew what the answer was. So it's okay that it doesn't look right. We just were using the picture to help us understand and to show Ms. Cronin that we understood. Right, this time we're going to have the alphabet on both sides. So I'm going to have 2x plus 7. I'm filling in my picture. 4x minus 3 is here, and the entire length is 3x plus 16. I'll do some algebra to solve for x. I get 2x plus 7 plus 4x minus 3 must equal 3x plus 16. Combine your like terms, and you have 6x plus 4 equals 3x plus 16. I'll subtract my 3x, get 3x plus 4 equals 16. So 3x equals 12, which means x itself must equal 4. Plugging that 4 in for AB, I get 2 times 4 plus 7 equals AB. So 8 plus 7 equals AB. So 15 is AB, and my work is getting real crowded here, so I'm going to squish it down a little bit. Perfect. And then I'll do the same thing for BC. So 4 times x, which we've said before was equal to 4 minus 3 must equal the length of BC. So I get 16 minus 3, or 13. And again in our picture, AB looks like it should be less than BC, but we drew our picture before we found our answers. So we didn't know that AB was going to be bigger than BC when we drew it, and that is okay. If it bothers you, add your little not to scale. If you're sitting here and you're going, Miss Cronin, I didn't understand any of that, here's a whole bunch of videos that can help you so that you don't have to sound like that and you don't have to be upset and cry. There's one about inductive reasoning, there's one about deductive reasoning, and then especially if you're struggling on that checkpoint, hopping into Khan Academy and going through that segment, addition, postulate stuff will be a big help for you there too as well.